While the sunlit side of Proxima B, a planet orbiting the closest star to our solar system, has been the subject of extensive research, its dark side has remained a mystery for years. However, the James Webb Space Telescope has finally shed light on this elusive region, revealing astounding data that has left researchers both shocked and perplexed. While one side of Proxima B is always illuminated, the other remains ensnared in perpetual darkness. Previously, it was believed that the dark side was lifeless, chilly, and desolate. However, newly released declassified photos have shown an entirely different sight. What are Proxima B's negative aspects? Unexpected emissions found from Proxima B's dark side provided startling hints. These subtle but enduring signals cast doubt on our knowledge of planetary environments because they point to anomalous energy patterns and infrared radiation, which may indicate the existence of localized sources of light and heat phenomena that are inconsistent with the planet's known characteristics. Do these emissions suggest anything much more unusual, or may they be a normal occurrence? Because of the irregular structure and nature of these emissions, some scientists have speculated that they might have artificial origins. Could it be that Proxima B's dark side is hiding cutting-edge technology? If these signals are artificial, they could offer proof of a civilization thriving in harsh environments. The difficulties of living in constant darkness might be overcome by using cutting-edge technology to provide warmth and light. The emission patterns suggest coordinated activity since they mimic urban lightning. The implications of such a discovery are enormous. If life exists on Proxima B, it may have developed technologies far beyond our current understanding, harnessing resources to survive in one of the galaxy's most hostile environments. Tidal locking on Proxima B creates a world of extremes. Could there be a society thriving in a harsh, lightless environment that adapts in ways beyond our understanding? A civilization might have overcome this difficulty by developing systems to transport heat and power to their shadowed realms. Doing so would require a level of engineering far beyond what is currently possible on Earth, providing new insights into what advanced life might look like. Permanent daylight on one side and freezing darkness on the other could result in temperatures so low that life as we know it would be impossible without a substantial atmosphere to distribute heat. Any form of habitation would likely rely entirely on artificial energy sources. The possibility of water on Proxima B's dark side was one of the most surprising discoveries. Although surface water is unlikely, there might be subterranean reservoirs protected from the hostile environment above water, which is necessary for life as we know it and whose discovery could indicate the existence of extraphilic organisms, life forms that are adapted to survive in harsh environments. If water exists, it would broaden our knowledge of habitability and provide insight into how life could be able to adapt to one of the most hostile settings in the cosmos. Despite these groundbreaking discoveries, the data begs more questions than it does answers. For example, where are the emissions coming from? Are they a phenomena, or do they portend something deeper? As experts continue to examine the data, the regularity of the emissions points to some kind of aim, but no natural process can adequately account for them. Are we seeing signs of a highly developed civilization, or is this a yet unidentified cosmic phenomenon? One thing is certain. Proxima B's dark side is a site of mysterious possibility and unmatched discovery rather than the desolate wasteland it was long thought to be. In a setting without sunlight, the presence of emissions from Proxima B's dark side begs the fascinating issue of what powers them, since conventional heat sources like solar power are unlikely to be able to provide the solution. According to one idea, the planet's core may be geologically active and produce geothermal energy. This heat might support dark side power systems and surface reservoirs. Another possibility is nuclear energy, a tremendously potent technology that could flourish in isolated environments. If these emissions are man-made, they might symbolize the operations of a highly developed civilization that has perfected this energy source, but whether they are natural or man-made, the energy source underlying them could fundamentally alter our perception of how power is generated in harsh environments. Unexpected patterns in Proxima B's tiny atmosphere, or what's left of it, have been discovered via more study of its dark side. Trace quantities of gases, including methane and carbon dioxide, were found, raising concerns about their source. These gases may have been produced by biological activities or by geological action. Methane in particular has led some people to hypothesize that it may be a consequence of microbiological life or something else different. The unequal distribution of these gases points to discrete sources that could be connected to the enigmatic emissions. Might this be a sign of life on the dark side of Proxima B or active processes? Proxima B is one of the numerous exoplanets that the James Webb Space Telescope has observed, but when compared to other neatly locked worlds, its dark side stands out as a singular mystery. While the majority of neatly locked planets exhibit significant temperature differences, scientists are hoping to find patterns that might explain its peculiar properties. Proxima B is an anomaly due to its atmospheric abnormalities and dark side radiation. The most contentious theory regarding Proxima B's dark side is the idea that advanced technology is at work. These findings imply that Proxima B may host processes unlike anything seen elsewhere in the universe. The more we learn about Proxima B, the more it challenges our presumptions about exoplanets and their capacity to support life. Could these emissions be the result of an extraterrestrial civilization? If so, their technology would be far beyond anything humanity has ever dreamed possible, allowing them to survive in an environment of perpetual darkness. The structured patterns of the emissions and the energy required to sustain them suggest the involvement of an intelligent force. Although this theory is still theoretical, it poses important queries about how life and technology might develop in environments very different from our own. Findings about Proxima B's dark side have reignited interest in interstellar travel, but launching a spacecraft to the planet is still extremely difficult. Organizations like Breakthrough Initiatives are already working on methods to approach Proxima B within a human lifetime, and the data from the James Webb Space Telescope provides a roadmap for future missions focused on the planet's dark side. The potential benefits make this a worthwhile objective. From the origin of the emissions to the characteristics of the buildings concealed in the shadows, these missions could provide solutions to the queries raised by Webb's findings. The dark side of Proxima B is more than simply a scientific conundrum. It serves as a mirror reflecting our own concerns about existence and whether life can persist in such harsh circumstances. What does it indicate about the tenacity of life across the universe? As we examine Proxima B's dark side, we are reminded that exploration is about asking new questions that push the boundaries of our understanding, rather than just finding answers to the ones we already know. The possibility of technology or even life on Proxima B challenges our preconceptions about what is possible. It inspires hope, curiosity, and maybe even fear, reminding us of how much we still don't know about the universe. Once again, the James Webb Space Telescope has shown its unmatched capacity to probe the unknown and paradoxically illuminate the secrets concealed in eternal darkness. Once believed to be a desolate wasteland, Proxima B's dark side now poses questions that test our comprehension of the cosmos. Are these discoveries proof of natural phenomena, or do they suggest something more remarkable? An advanced civilization thriving in circumstances we can hardly comprehend while the answers are still elusive? The options are many. The information from Proxima B's dark side motivates researchers and idealists alike to push the boundaries of our understanding of habitability, technology, and the tenacity of life. It serves as a reminder that even in the wide void of space, there are surprises just waiting to be discovered. Exploration is about kindling curiosity and bringing people together in the search of the unknown, not simply about finding solutions. The dark side of Proxima B serves as a warning to the next generation of explorers that the cosmos still contains mysteries that might fundamentally alter our perception of reality. If you like this video, please press the like button and subscribe to see more videos like it. More reflection on the characteristics of Proxima B's emissions and the causes behind them is encouraged by the enigma surrounding its dark side. Is there anything more intricate at play, or may there be unidentified natural phenomena at play? The idea of highly developed civilizations thriving in such harsh environments challenges our perception of the boundaries of both technology and life itself. What if Proxima B has life forms that we can't even begin to comprehend? Life on Earth has shown amazing flexibility, yet there may be a chance for life to endure in such a harsh, dark environment. The cosmos itself could astonish us more than we could have imagined. Now, scientists must tackle the difficult challenge of evaluating this new data in order to develop logical hypotheses and solutions. Every new space discovery advances our knowledge of both the planet in question and more general issues about the presence of life in the cosmos. At the heart of these revelations is the fundamental question of how the existence of a potentially advanced civilization on Proxima B alters our understanding of life itself. The discoveries on Proxima B, particularly with regard to the enigmatic signals and potential energy sources, could drastically change how we approach the search for life beyond Earth. Are we truly alone in the universe? Or is it possible that other intelligent species have learned to thrive in circumstances that we might consider impossible? Our presumptions about where and how life may thrive must change if civilizations can emerge in environments so unlike from those we are used to on Earth. This has enormous ramifications for space travel. What if further explorations of these worlds result in even more significant findings? The possibility that intelligent life could adapt to environments very different from our own pushes the limits of what we think is possible. As scientists continue to study Proxima B, their findings may eventually lead to technological advancements that we have not yet imagined. The search for energy sources that could sustain life in places without sunlight could have enormous benefits for us here on Earth, especially in developing sustainable off-grid technologies. The possibility of using nuclear or geothermal energy sources in a way that could apply to our own technological challenges is an exciting prospect that goes hand in hand with our growing understanding of the universe, and the emotional impact of these discoveries is not lost on those who have dedicated their careers to space exploration. Research is constantly being advanced by the thrill of discovering new facets of a far-off world that might hold the answers to long-standing questions, but it also makes us more aware of how much more we still don't know. As the journey into the unknown continues, each new layer of mystery reveals yet another question that broadens the horizon of possibilities and forces us to reevaluate what we already know about space technology and life. The shadowy aspect of Proxima B represents what we still need to investigate. The enduring enigma concerning the emissions of the planet, the combination of the feeble indications of life, and the possible existence of water creates a mystery that will likely enthrall scientists for years to come. If we can learn to adapt to and survive in the most hostile environments on far-off planets, it will surely teach us important lessons about the resilience of life and the significance of discovery. This journey is not just about discovering new information. It is also about reshaping our understanding of life's potential in the cosmos. Proxima B has emerged as a key location for future interstellar exploration as well as exoplanet research. In the end, the mysteries of Proxima B's dark side serve as a reminder that exploration is fundamental to our nature. It's not just about finding answers. It's about continuing to question, wonder, and venture beyond the familiar. The questions it raises about life, technology, and survival have already sparked new ideas and initiatives that may one day take humanity to the stars. Every new finding, no matter how little, raises a whole new set of inquiries. As we look to the future of space research, the dark side of Proxima B, with its peculiar emissions, possible technologies, and mysterious energy sources, is just the start of a deeper investigation into the unknown. It is a call to action for the upcoming generation of explorers to push past the limits of what we currently know and to embrace the unknown with open minds and hearts. Proxima B is a constant reminder that the universe still contains mysteries that could test our very understanding of life, the cosmos, and what is possible. The hunt for solutions is far from over.